Objective 2.1 is all about reading and extracting information from the periodic table. And what we're going to do is we're going to go through an example using rubidium, and we'll go through all of rubidium. So the atomic number for rubidium is 37. The atomic number is always found at the top. It may be the middle or one of the corners, but it's always at the top. So 37 is for this one. Atomic mass is always found at the bottom, and this is your messy number. Now, the atomic mass for rubidium is 84.468, and they don't have the label on here because it would be a little redundant, but it's AMU, which means atomic mass units. So when you're stating your atomic mass, you need to have a label because it is a measurement. A way to remember that atomic mass is the messy one, meaning it's usually a decimal, is because when you mass something on a balance, you're typically not getting a nice, even whole number. And that's the same thing with atomic mass. And we talked about the reasons why, being it's an average of all the masses, and the masses that you're adding up, protons, neutrons, electrons, aren't exactly 1, 1, and 0 as well. So that's why it gets messy. Now, mass number is when you take the atomic mass and then you round it to the nearest whole. So in the case for rubidium, it should be 84. And the reason why is because you always look at the 10th digit. And the 10th digit in this case is 4. If the 10th digit was 5 or above, we would round it to 85. But because the 10th digit is 4, and if it was below 4 as well, then we would keep it as 84. So we always round it to the nearest whole number for mass number. Protons is the same thing as your atomic number. So for rubidium, you should have 37. Electrons actually is the same thing as your protons. And the reason why is because protons carry a positive charge. And that means if you have 37 protons, you're going to have a positive 37 charge from that particle. Well, we know atoms are neutral, so therefore we need the same number of negative parts. So to cancel out positive 37, we need negative 37. And how we're going to get that is we're going to have 37 electrons, which would give us that negative 37 charge. And when we put that together with positive 37, when they come together, they cancel each other out and have a 0 or neutral charge. And that's what we're looking for. So that's why the electrons are the same. Now, neutrons use the equation mass number minus protons. So the mass number we found out was 84, and the protons is 37 from the atomic number. So when we subtract those two, we should get 47. And the reason why you can use this equation is because your protons and your neutrons are what give you your mass number, because most of your mass is found in the nucleus where both of those are. Electrons do have mass, but they really don't account for much of the mass of the atom. So we just kind of use this equation and negate the electrons here as far as mass goes. So why don't you pause and try this example, and after you pause it, I will give you the answers. All right, so for the answers for plutonium, the atomic number is 94. Again, the top hand corner. The atomic mass is 244.064, and I've made an error here. I actually should have put AMU, and I didn't, and I apologize, but that should say AMU behind here. The mass number is 244. You do not need a label for that because that's just a number, not a measurement like atomic mass was. Electrons are 94 because we need to have the same number of those as protons, which is also 94, which is your atomic number, and neutrons is 150. And I got that by 244, which is your mass number, subtracting 94 would give you your 150. If you need more examples, there's more examples in your activities folder. You can play Battleship. There's a lot of different things that you can do. Also, asking Miss Peters for help would be very appropriate as well. But again, this skill should be something that you can do easily and can do without using your notes. And we'll be using this the rest of the semester. Let me know if you have questions.